but we have not really gone through it. Starting from the scratch of his question and going through, that might take some time. But I don't know. I will encourage you to maybe just watch the last part of last week's video, maybe the last 30 minutes. You get that question and see those areas. Then maybe after that, then you can ask your question. Please. I don't know if that is okay, Dr. Mani.
It's okay. Oh, I
Okay.
didn't mean that that you should go back. What you were saying, you asked a question that should you go back to that question and just have a recap. So I said yes. Yes, please go back so that some of us that were not in the class can catch up.
All right.
It's
Okay.
not like I'm saying yes. That's what I meant.
Okay. All right.
Please let me just tell you people now that me, I'm taking attendance, and when we are going to write CAT, if you don't miss 75% attendance, you're not going to write the CAT.
Okay. Dr. Please go ahead.
Okay. Thank you. If I really understood very well about negation, okay, I think is when you ask, when you give a command with negation, I think it's supposed to give you the opposite of the true result.
That's correct.
So, but when you're going through the data, so data, you are asking to remove FCT and let it remain other states. But I thought it should have been giving, it should give you opposite of what you commanded it to do. I was thinking, can anybody say, okay, since you want FCT to be removed, you can say, okay, remove other subjects and leave FCT and the other, I think MCT or whatever, so that it can be the opposite. I don't know whether you get what I'm trying to figure out. By my understanding, I think negation should be opposite of the two.
Yes, it is.
Yes, but in that, doing the data analysis of those that you showed us, you now commanded it to, if you can remember, to remove SCT, which it did by your own command. I was thinking it should be the reverse.
Okay, all right. Yes, I do. I think I'll just repeat that example. So your question is similar to that of Dr. Amani. So I think I'll just join both and repeat the example. But in order to make it come home, I'm going to use another method to answer this question. I want to introduce us to data. R was built mainly for data analysis. So R also comes with a lot of other data apart from, what I mean by that is that R comes with some inbuilt data, and some of the packages also comes with data that you can work with, so that you can tinker with. So like now, I want to write a command, data, open and close. If I press enter, you see what just happened. So these are data sets in R that are available freely, that can be used for analysis, for training, for for rehearsals, to just work with data. So I think I'm going to just pick one data set from this set to for us to tinker with it as we use the negation and the double equals to work with it. So let me look for anyone that might look promising. I think iris. I saw iris. Cause okay, let's go by iris. Let's use iris. So if you look at this place, this is iris, and this iris is based on Edgar Anderson's iris data. So this is a freely available data set. So I want us to use this data set for this. So let me create a new script. I just press Control Shift N on my screen. Whatever I got this new script. You can automatically do this by going to File, New. Oh, why is my file all blank? Oh, this is strange. Anyway, well, I did Control Shift N. So remember I first did this. Okay, now the next thing now is that I want us to use the iris data. So if I just type iris, RIS, and I press my Control Enter, Control Enter, or I click run. So you see this is the iris data that has come up. Okay, so I can decide to view it in the on my script pane here. So I just click run. So this is the iris data. So I would like us to use this data to work with it. So now if you watch, this has like 150 rows and five columns, as you can see. So you can see the species column has Setosa, versicolor, virginica. So it has just three. Good. So I think this is data. This is good data that we can use to do what I want us to do now. So now, based on the Dr. question and based on what the money also said that we should go through. So I want to use the negation and the equality logical function to tell R to give me back this iris data, but I want to see only Setosa, and I don't want to see vesicular, I want to see virginica. So to call up that command, now, and then I want it to come up in this script pane, not in my console. So I'm going to call up the view function. So this is capital VIEW. Okay, I call it up with my open bracket. Then I now call up iris, because remember that this iris is inbuilt in R. So despite that, you can see my environment is empty. Okay, but you can see it's R recognizes iris as an object when I call it, because it is there inbuilt in R. But in my global environment is empty. But if you call iris, R knows it's there because it is inbuilt in R. So I now use my open square bracket, and then I'll now write iris. I now club the same object iris. I now use the $ to go deeper into iris. So I want iris. I want to go inside species column in iris. Now I now say species equality, that is double equals to. Because this is going to be a string, I'll now use my double apostrophe. Then I now write the spelling must be correct, everything, because once anything is not there, I'll bring up an error message. And I write Setosa, and then after that, I now put a comma. Now the reason for this comma is because using square brackets means you are going inside the data, going inside the object. So I expect you to give this two coordinates, that is an X and Y. By that, I mean you give it the rows and then the columns. So I've already defined it. I've already defined the row by this whole aspect defines the row. So the row here means that R should keep rows, should keep only rows that the species has setosa. So, but for the columns, I'll leave it blank, meaning that should give me all the columns. So that's what this command means. So if I should now run this, good. So we see now we now have 50 entries. So you can see it's only setosa that is here. And so if I want now, let me repeat this command here. And then I now want R to give me only those that are not setosa. That's why I introduced this negation sign. If I now run this, so you see this is basic color and beginnica only, and that is just it. Okay. Now let me still make it a bit clearer why this comma is there. Now, so I want to see if maybe we can specify a column. So let's see. Okay, let me look at the data and see which column I can specify for R. Okay, let's say I want R to give me you know, this is column 1, column 2, 3, 4, 5. So let's say I want R to give me just the petal width alone. Okay, so petal width alone. So that will be number 4. So if I now come here and type after the comma, I put 4. If I now run this, so yeah, comma 4. Let me remove the view function and see. Okay. Okay, it showed up here. That's the values, but it didn't show in the view. I want to understand why R behaved this way. Okay, okay, okay. This gave me only the data. Okay, let me try to tinker with this a bit. Let me use the C command and put 5 and see if it will run. Okay, all right. I think I know what happened. Okay, so this is what happened. Okay, let me repeat this so that you get the feel of it. Okay, so I first ran this command in line 9. I first ran it, and this was what R gave me. Okay, so actually what happened here was that I only told R to give me uh, to bring out all the data sets that the species is a Tosa and is only in column 4. So, and that is what is here. So, but this data alone will not show well on the script because it's just data, like it's just raw data without any other thing with it. So, but when I now modified um the command to include both 4 and 5, and if you remember our Irish data, let me show it again. Remember our Irish data, this is column 4, this is column 5. So I tell you to bring up column 4 and column 5. So when I now specified both, it now brought up because in this script pane, it shows you data frames. It shows data frames better than other data. Like where you want it to just to work with other data, it may not show well here, but on the console it shows. So that is how when I now gave it this command. So I now use the C to concatenate. Because if I just type 4,5, R will be confused. So I have to put them both in brackets using the C, using the concatenate command, so that it will to bring up those two rows only and show me. So I believe this might answer the question of Dr. Shinyeri and Dr. Mani. Can I get any comment from them? Is this clear at this level?
Yes, I can go ahead. Thank you.
Okay.
Well,
Dr. Shinyeri. Okay.
you can go ahead, but what I honestly that what I honestly that the negation sign answers in two ways. If you ask him question, what is true, you can turn it to it will bring it in opposite direction. Another thing is that if you command it, it gives you what you ask him to do. But you can go ahead. Let us not waste for that time.
No, sorry, I want to understand. Okay, you said the negation sign answers in two ways.
Well, don't worry. Go ahead, sir. Go ahead.
Okay, though anyway, it's not really. It's okay. How do I put it? Um. Now, this double equals to is logical function, same as this negation equals to. They are logical functions in that what their output is true or false. Okay, so ordinarily if I should really break this down thoroughly, what this line 6 is saying is that I want you asking out first. You want to view this in the script pane, okay, and the data you want it to go into is iris, and then you want to go into the species column of iris. Then you now put this logical function where you're now saying is iris dollar species equals to setosa. So so if the answer is true, then it should bring out that the lines with it only. So that's what, if I should break it down into the real logical thing. So if this is true, then show it. And then the same thing for this line 8, for instance, now. So this is saying that if this is true, then show it. As far as you know, this being true means that Setosa will not be there. So if this is true, you show it. So that is what this means. That is the logical thing. Remember, logical is true or false. So this works on if it is true, then show it. That's what this means. So well, maybe later, I don't know, but I don't know how else I'll try to break it down. But Francis, I know you may have missed some classes. Have you been able to go through any of our past videos? Okay. Sorry about that. Sorry. Maybe I'll share the videos with you. Okay. All right. Okay. So let me close this. Any comments from anyone so far? Any question, please? Any comments or questions so far? Okay. So in the absence of any, let's continue our tutorial. Okay. So I'm still trying to work up a new script for our use. So I've already gone through data, which shows us the various data sets available in R that we can use, to practice. So maybe, for instance, now you can decide to call up this. So maybe let's call up air passengers. If I press enter, so this just shows us this is the data frame. So just anyone. So they all have, can decide to bring them to the console and press enter. You see what data is about. So different types of data that can be used for training. So and then I try to show here this any row function. So this n row is used to um to ask R what's the number of rows in an object. So for instance now this is air quality. So if you remember, there is air quality here in the data sets. Air quality. Seems air quality. Okay, there is air quality. Air quality. Trying to find it. Well, it's there because R is able to catch it. Air passengers. Okay, good. This is it. This is air quality. It's about New York air quality measurements. So this is the data. So if I may bring it down here and call up the view function. So this is the air quality data. It's about 153 rows. So so for us to just get this number of rows, we can easily just pass the n row function. So just say n row bracket air quality, and you see it gives you the number of rows. So the same way you want to know the number of columns, you can just write ncol air quality. So it's 6. That is same thing here. So okay, one may wonder of what use may is there for one to know a number of rows, number of columns. There are instances where you need it to pass a command. It depends on the usage. Okay, maybe I should just also, okay, still on this. I remember there is this and this or. Like here, let me leave this because it'll be like moving into a different thing. Okay, let's just stick to this for now. And then this function in line 8 is asking R to check if there are missing values in a data set. This is is.na. Remember the last time we did na.omit. Na.omit was for R to remove rows that have missing values. So this one is a logical function that tells R to check if there are missing values in the data set, and if there are, it should if there are values, then it should return true. There are, it will be false. But the command will check the data sets, all of them. So remember, like now for our air quality, remember that this is the air quality. So we should pass this command, this is .na. So you can see this is what comes up. It tells us where there are missing values or not. So anywhere you see true means that there are missing values. So we can cross check. So we can say that in row 5, missing values under ozone and solar R. So we can take that out. So let's check row 5. You can see it here. So this is missing. That's why it's called written NA. So we can use the is.NA to just quickly scan through R to check where there are missing values. So that is about the is.NA. Then this one is complete.cases. So this is also a logical function for R to check if each row has missing values or not. So it takes each row, unlike, so is.NA and the line 8 and line 9 commands are similar in that the line 8 checks for individual data in the data set, while the complete of cases checks cases. You know, a case is a row in R. A case is a row. So if there are any missing values in any row, it returns true. If there are none, it will be false. So by that, if we should look at this data, so it means that, for instance, now line 1, 2, 3, 4 should be true, while line 4 and 5, so while line 5 will be false, because line 5 has some missing values. So let's run the command and see. So you can see, so 1, 2, 3, 4 is true, while 5 and 6 are false. So that is what is here. So 5, you see, 5 has true here, and 6 has a missing value here. And you should also confirm it from here as well. So you can see, so line 6 is not complete because it has a missing value, while line 5 has 2 missing values. So the complete dot cases command, it checks each row, and whether there is one missing value or 2 or 3, once there is at least one, it returns it as true. So I hope this is not confusing, because the true and false thing it may be a bit confusing, but I don't know. Are there questions on this?
Would you please re-explain these complete dot cases again?
Okay. All right. So complete dot cases is a function that asks R. But bear in mind that case in this context means row. Each row is a case. Okay. Like here now, you have 153 rows. So we have, this is row 1, row 2, row 3. You have here, you can see row 1 to row 12. So it's like saying we have case 1 to case 12. So each row is a case. So bearing that in mind, so this command in line 9 is asking R, check all the rows or check all the cases in these data sets, from beginning to the end. And then if each one has no missing value, then that means it is complete. So return true, it's complete. But if anyone has any missing values, whether it is one or more missing values in all the in each data in the set, then bring out false. So that's what this function here is asking R. So if it is complete, then it is true. True is complete. If it's not complete, then it is false. So that's what this command is asking R. So you may wonder, what is this command? You may have data that is big, Take for instance, now you have maybe you did research and you have such data that you have in your laptop, So it may not be easy to use your eyes to check if there are anywhere that there are missing values. So you just load the data into R and just type this complete dot cases, and I also need to understand how R brings up output too. If you look at this one, that it does everything one after the other, here it brought up the rows and the columns, but here there's no such. It's just here as a whole. So, but we know that each of these represents a row. So this is, you can see that there's one here, 16, 31, up to 151. Remember that this data set has 153 cases. This 154 refers to this one. Remember that this is 152, this is 153. So this is the total number of
Okay.
cases.
I was about to ask again because I think that R sees each of these row as a case. So I was wondering why it has it arranged this way. But since you explained that this 151, this is 1, this is 152, and then this is 153, that makes it clearer.
All right, okay. That's okay then. So, all right. Okay, so now in line 10. So in line 10, remember we did this NA dot omit last week. So this NA dot omit is now asking R. There are many ways one deals with missing values. Okay, so you may decide that you don't want to spend the time working with any row that has missing values. You just want R to just remove, remove any row with missing values. So in essence, anyone that's complete dot cases is false. Remove it. That's what this any dot omit does. So if I decide to just run this function alone, for instance, remember that this data set equality has 153 cases. So if I should now run this, for instance, now you can see any dot omit equality. Okay, it has removed quite a number of rows. Like if you watch here now, row 5, row 6 are not there anymore. Row 5 and row 6 are gone. I'm having some issues here. So row 5, row 6, even row 10, row 11, so it has removed them. So but here I now put R. Okay, this function, instead of showing me the output, save it into an object called air. So I can start to run this command as a whole. So you can see it run it. So it saves my output pane, my console of having to show everything. So it just saves it into this object called air. So I decide to come here and there's this arrow here. This will just show me a summary of the things in the object. So you can see ozone, solar R, wind, which are also the same things here. So these are the columns that it shows here. Then this attribute shows, kind of tries to explain the thing that it had to remove. So this refers to the type of column. This is integer. This is numerical. Integer different from numeric. They are similar. They are numbers, but numeric means it has decimal places. Integer means whole numbers. So that is what this means. So I can start to click here so as to view it. By click here, it comes up. So the function is like clicking, like typing this command, view air. So and that comes up. You can see it has removed number of rows. So now it's now 111 rows. Okay. So another way is to you can now write number of rows air. You can now pass this command. You see 111. So that is what has just happened. It shows me the number of rows here. So I don't know how so far is this okay? Are we following, or do I make it more practical to show how it can be applied? What do we think so far? Any questions, comments?
Uh-huh. I think since we have our data in R already, and then we have the benefit of the Zoom, we should just try to, if it's just to call forth a function or use one of those things that you've taught us, and then we should share the screen. That is where we get to see our mistakes, what we are doing wrong. Because when we make mistakes while writing scripts, it's always a big headache. So I think we should do that. We should one or two people should share their screen. They are going to see, oh, you're doing this wrongly. You did this right. Yours is correct. Because we are accumulating knowledge already, and then we don't know. Maybe we should work with a data. We should try to see the number of rows, see the number of columns. We should use some of these functions that we've showed us before it gets more complex.
Okay, I'm trying to put together what you just, okay, so you're saying other participants should kind of practice this right now. Okay. Okay. So Joshua made a suggestion so as for us to have maybe practicing session. So who would want to begin? Anyone? Hello. Are we together?
Yes, sir. I find it difficult to open my R. I don't know if any other person is experiencing such.
What happened? What does it say?
It's taking longer than expected. Does it take long to load?
Well,
On a
it's
16
not
gig,
really
on a
usual.
16 gig RAM.
Okay, Dr. Chinyere, is your R open? Is your R open?
Okay, not. Let me try it.
Okay. Hello, are we together? Network seems bad.
Yes, we are together. The R is coming up now, but it's very slow. I wonder how slow it will be on people with 8 gig RAM laptop.
How are you doing? Once you share your screen,
Yeah, but my R is still loading.
to show the NAO
So
meet.
you wonder how it will be in our type of life.
Network is bad. Network is bad. Network is bad. Okay, maybe while we wait for people to get their R's up, let me just quickly show the other ones. Let me just run through the rest of the commands. Like in line 16, now these are ways of generating numbers fast. You just type 1:9, R generates integers from 1 to 9. Then if you do the reverse, big number is a small number, R generates integers from that to that. So like now, if we should run this, you can see 1, 2, 3, 4, 2 to 9. And if you run the other one, you can see it gives you numbers 879, all the way down to 767. So this is a way to generate numbers. Then this also is a way to generate numbers also 100. You now but you use the seek function. So you tell our seek starts from 1 to 100 and increase by 1. That like saying from 1 to 100. So if you run this, it goes 1, 3, 4 to 100. Then it when I ask R, okay, give me 100, but increase by 2. So like saying 1, 3, 5, 7, 9 and all. So we should now run this. You can see 1, 3, 5, 7, 9, 11. So this has run. If you wanted to be by 10, that's like 1, 11, 21, blah blah blah. So you see, yeah, that long. We've been cut off, right?
And that jokes. It's really not. It's really not. Really not.
Yeah.
Interesting.
Okay.
Yeah, but
So and then this now line 22. This one using the length dot out syntax under the seek function. So this you just want R to be 4 numbers between 1 and 100. So if we run this, it gives us 1, 34, 57, 100. So it tries to share it out between 1 and 100. That's what R does. That's what R has just done here. So okay, here using along dot width is when you have an object like this is an object called gender, but we've not yet created any object called gender. So this function will not work because R has no object called gender except if you create gender. Let's say I will create an object called gender. I'll just use just some random this because okay, now let run this so that you see that R will give me an error. If I run this, tell me object gender not found. But if I now have to save this gender and then I now run this. So this will now be along with it's like saying number of things inside gender. It's 3. So I'm telling R instead of saying length of R well out equal to 3. I'm not saying it's along dot width using the number of the number of data in gender. So that is 3. So if I should run this, R will give me 3 numbers. So you see 1.0, 50.5, and 100.0. So like say R divide this from this to this into 3. Just give me 3 numbers only. So that is what just happened here. If I can increase this to 4, it will be the same as length dot equals to 4. So if I should save this and then around this, so you see something. So like let R divide this range of numbers into this number of numbers I want and show them. So that's what this does. I hope I'm still audible. It's raining here heavily, and I don't know how strong network is. Am I audible?
No, it
My
won't be.
my R is on now.
Okay. All right. So let me stop sharing so that Josh can do a hands-on.
Will you stop sharing? I need to copy from your script.
Sorry?
I need to copy these lines from your script.
Oh. Okay.
Both of us share our screen.
Sorry?
And both of us share our screen.
Okay. Honestly, I don't know if Zoom is capable of that, but try it out. Let me see. Okay, yes, we can. Let me enable that function. Okay, go ahead. I think we can do that now.
Allow me to share them.
Okay. That's please, can you off that AC? The AC.
I've shared my screen.
Is that one seeing his screen? Okay.
Yes, I can see his screen.
Yeah.
So what I did was that I moved
Sorry, we've been having network challenges. Dr. Money, can you hear me? No. Talek is back. Dr. Money, can you hear me? Can you hear me?
Yes, I can hear you.
Okay. Sorry, but even over there, I guess you are at Anilea.
It's raining on this side too. It's
Okay.
raining at this side.
All right. Thank you.
Eh?
All right, thank you. Mr. Josh, what's up? Can you come up?
Yes, I'm trying to. Okay.
Maybe if you reconnect, click the link again. All right, your screen is up.
My whole screen. Now, wow. People, they read my chat. Okay, this is my R, but I'm not able to download the script that you sent to me. Okay. So my screen is on, right? First thing I did was,
Yes, it's on. Yes, go ahead.
okay, let me do that again. Data to call forth previous data that are already embedded in R. Enter. Then I have this different data sets, and these are their names. Then to pick a particular one. Let me see. I saw formaldehyde. That seems like a name I'm familiar with. So I say data slash. Yeah, I want to ask a question here. Do I need to put this in inverted comma?
Well, this is another command that you are calling. You are calling data with the object. This will load the data in your objects. So you are not supposed to put it in inverted commas. It's supposed to be called directly.
By saying,
just press up in your instead of having to copy and paste.
Okay.
So remove the inverted comma. So press enter. I can see a mistake. Am I audible? Okay, it's out. I'm connected using my Glo right now. Yes, the F was lowercase. That was why. Starlink is out. But Dr. Francis, can you hear me? No, I mean right now. But I also on my Glo hotspot. So if Starlink is out, I don't get disconnected. So we're still waiting for Josh to come up. So we can see what happened to Josh. You know, R is very sensitive to cases. You know, it's case sensitive. Where you're supposed to put a small letter, a small letter. If you miss any of those, it will link up an error message. So the formaldehyde data, the F was capital, while the rest was small letter. But what he did was he put all small letter and R kept returning errors. So if you do it in the right way, you shouldn't bring up any error. So maybe while we wait for him to come up, maybe I may just redo what he did so that we can see it. I guess my screen is visible to people online. Okay. So what he did was he did data formaldehyde. So did you see what happened? R actually corrected me. I typed, let me repeat what I did. I typed FORMALDE. So you see R already brought out the correct thing. So it required me to just press enter to select it. You can see it already brought it out. So once I press enter, it puts it the normal way. So it's, and then you can see it now gets saved in my objects, but it's still kind of hidden. I'll have to call it out for it to show up and be properly put well. So basically, even without using the data core, you don't want it saved in your objects, you just type it. R knows it's an object in itself. Let me check if Mr. Josh is back. Wow, Starlink still out. Okay, Opportunity is back. So Josh, are you back? So you can share your screen. Okay. So Josh, I think you should repeat what you did earlier and then be a little bit patient because R has a way to show you the correct thing. So repeat that data and then formaldehyde using all small letter.
Okay, using all small letter.
Yes.
So I said okay. Data. Okay.
Good. So now can you stop?
Yes, sir.
Good. Can you see formaldehyde written there already?
Yeah.
And it is already highlighted. So if you press enter, R will format it for you and study it for you. So just press enter. So do you see what just happened?
Yes, sir.
So with this, you can go ahead and press enter again to run the command. So you see, it has run.
So from this data set now, we see that this one has 6 rows or 6 cases and then 2 columns.
That's correct.
Yeah. If I can download the script that you sent me so that I can run any other command. or if you can share your screen too.
Okay, well, maybe I don't know why it's not downloading. Okay, let's continue. So let me share my screen as well. So I don't know, any other questions from other participants or comments? So is my screen visible?
Yes, sir.
I think Josh's screen too is also visible, right? Okay,
It is.
It is. You can see both.
Yes, sir. You have to click it. Oh, you have to click which one you want to view.
Because I'm just seeing this Zoom function. Is my first time of seeing that other persons can share screen. How do you?
Okay.
I should click on Dr. Inyanya.
You have to click which one you want to view. Just go up. You go up. So you will see both Joshua and Dr. Inyanya. So you click which one you want to view. It will show his screen. Okay. I understand.
Okay. All right. So let's continue. Okay. So we are now in rep function. I hope we understood this along with and length dot out. So we can move to the rep function. So rep is also a way to generate data, whether figures or characters, is a way to generate multiple of something. So that rep is like repeat, the repeat function. So if I should just run this command, you see it repeats the string mail 9 times. So that is what this does. So it gives me 9 mails, and then so if I should run this as a whole, if you just create an so that is out. That link is out.
Yeah, put it up.
Sorry to our online participants. Okay, I guess should we just end this? This class is crazy. I think I should apologize to our online. Okay, I think Dr. Money that's here. We've been having lots and lots of issues with Starlink, the rains. So
Why are you apologizing?
okay. So
It's not your
maybe
fault.
so I guess maybe we should come to an end. Then we continue next week. So any questions or comments? Dr. Mani, any from you?
No, for now.
Okay.
No question for now.
Can you receive through Bluetooth now? What's your Bluetooth name? Joshua. Oh, it's asking to authenticate. I don't want to authenticate.
Dr. Yang, thank you, sir.
Yeah. Oh, Dr. Chi. Oh, I missed you. I didn't know you were also online. I don't know why I assumed you were here. Don't mind me. Thank
I'm
you.
online,
Thank
sir.
you. Yeah, well done.
Thank you, sir.
Yeah. Okay, Josh, sorry, a minute. Let me send it to your Bluetooth so that you can share. It's unable to send through Bluetooth. I don't know why. We're waiting for Josh to come online and do a little bit of practice.
the script now. Can everybody see my screen?
Yes.
So so data. Okay. I'm going to be choosing Nile, flow of the river Nile. So
Actually, you can just type Nile without data if you wish to see it. But if you wish to save it environment, that's where you may now call up data.
okay. From here I can see that it has 1 to 91 rows. No, 1 to 92. 1 to 100. 1 to 100. Can I do counts to know the number of data?
Yeah, this is a practice. So try it out. If you get error, you try to find out what happened.
Okay.
So there is no function called counts currently. You know, functions are based on packages in R that you may have installed and loaded, or those in base R. So I can see from the error message there's no function called counts as of now in your R.
Okay. So in this case, if I want to know the number of my entries in now, how do I find out?
What I can see here, this is not a data frame. It looks like a vector. So I'm trying to use the length function, length. Okay, we still got an error. You know what? Type LEN and wait. I've seen the error in your head. So you see LENGTH. You want to GH. So press enter. Then NIL. Aha.
Okay.
So have you seen? So do you understand what just happened now?
Yes, I do.
So sorry. So what you're showing here, the numbers here are up to 100.
Exactly.
Yes, it means 1 to 100. Yeah. Yes.
Yeah, you know, he's coming from, I think, like, because I can use Excel. Count is the function used in Excel. But in R does not recognize count as a function. So you use length because from the data here I can see now it's a vector data. So that's why you can we use the length function.
I want to look for the number of rows now.
Anyway, error will likely bring up an error because it is not like in the document, but if you go ahead, we are all here to learn.
Okay, I want to know how you were able to look at data and say this is a vector and this is a data frame.
Okay, go ahead. So you see, it is null.
No.
Because that is not in the data frame. You know, the data frames are two-dimensional. it has rows, it has columns. If you look at that data, it just traits in that R listed it from 1 to 1 this to 91. So and every data, it's separated each data using tab, like do like now you see first one was 1120, then tab 11260 tab 961 tab. So that shows that this is a vector data. The data structure is vector because it's 11111. But if it is a data frame, you have columns, if you have rows. That's how we know. That's why length will work in this way. So if you type length for data frame, it will also bring up an error or null. It will work. You need to specify whether you want to count the rows or the columns. But you want, that's where this can work. Except you want to find for everything, you may now find a way to multiply rows and columns, then you cannot get the same number of everything in the data set. I don't know if that's clear.
And we have a function whereby we check if, since what we have in this data is like they're all integers, and we check if we have a value that is maybe greater than a particular number or less than a particular number.
Okay, like now for these data sets called Nile, I want to check the number of values that are, let's say, above 900.
Yes, sir.
Okay, sure. We can type the function. We can type the command that can get that out.
Because I realized that there is little we can do since this is not this data is limited. You cannot check for
check for what precisely?
If any of the value is missing, because if any of the value is missing, that means I've even omitted it.
Yes, it's complete.
Everything is complete, so we cannot check for either on the row or on the column if any of the values are missing.
No, but sorry, but no, you can still do it. So you can just type is dot any Nile. Then you see that everything will return false.
Let me try, sir. So no value is missing.
Good. So now, okay, if you want to get the number of values that are above 900, we will type like length brackets Nile.
This length?
Yes, just press enter. It will bring up that one. Length bracket Nile. Then square brackets, open square brackets. Open square brackets. Then type 9 again. Then type greater than sign. Then 900. Press enter. So you see, I mean that there are 49 of them that are 900. So for us to confirm this, we'll use another function, another command. We will now type Nile greater than 900. That's all. Then we'll now see how many truths are there. So if we count the truths, that should be equal to 49.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. Correct.
Yeah. So to still further confirm this, we can look at the raw data. Like now we can see that from 1, 2, 3, 1, 2, 3, 4, 5, 6. The first 6 are true, and the 7 is false. So check the raw data. You can scroll up to that one. Let's just do a final confirmation. Go up again, like the data itself. So you can see, you can see, yeah, good. 1, 2, 3, 4, 5, 6. You can see it. They are above 900. That one was 813. You can see it is less. So you see that. You see how R has obeyed our commands.
Okay.
Yeah.
The other ones I would like to ask is if we are picking an Excel file from maybe that we've stored our data, and then we want to check all these things on it.
Okay. Do you have an Excel file in your laptop?
No. Can I quickly create one?
Sorry?
I don't have an Excel file already saved.
Okay, because no, this is practical. If I should not stock without doing it, we not learn much. So it's better when there is data sets that we can now use to practice.
I'm putting up one already.
Okay. Well, I do. I have many. Yeah, but you won't learn much from me because mine will be like perfect. But when he does and makes errors, we learn and we try to find his errors and solve it. It's better for one of you to do it. Since it's hands-on, you learn more. But if I do,
I have one now.
I'll be very fast.
I have one now.
Okay, good. Because there's a lot to call up an Excel file. It's a lot. If I do myself, you're not really getting that much. So first of all, you need to load a package. You need to install a package. And then, okay, let me get a package name. You need to install a package, and then you need to locate where the path of the file.
Okay.
So okay, now type install. I want to get Excel. Okay, good. So click install.packages. No, the first one, please. Okay, just type right A. So just press enter. You don't need to use your cursor. You can use the cursor to go up, down, and then press enter for select. Good. So now type READ. I'm sure I'll bring up the correct thing. Good. Read Excel. Okay, type X. X. Good. Press enter. Now you want to install a package. R on its own cannot read Excel files, but someone or people somewhere have created this package called Read Excel that allows you to read that expanded R to be able to work with Excel files. Now press enter. So R will now go online and install this package in Joshua's computer.
That will allow me to always pick Excel file from my local drive.
Good. But the people that created, I want you to expand this console, make it big, make it cover your script by clicking the big good. Okay. It's okay. Now, this package called Read Excel, Read the Excel. It's a package, but it was designed to work with other packages. In that, it is a package that has dependencies. So like now, if you look at his screen, you can see there were like many other packages that was installed alongside it. It itself was the last look package with Excel, essentially unpacked and MDS some checked. So all the ones above are also different packages. But with Excel cannot work without installing those packages. So that's why R all those packages before it now installs the last one. With that, the package will work perfectly. Okay. Now with this done, okay. Do you know where that file is located in your computer?
Let me quickly check.
Okay, go ahead. Dr. Shinyere, you have a question?
I think still Joshua's slide.
Yes.
Like here.
Yes. I'm not sharing my screen.
No,
I'm making a dark thing.
you are saying he has to download a package that will enable him to use Excel.
Yes, he just installed it.
Okay, I saw it.
Yeah, that's what he just finished. That back of the screen. So, but now the package has been installed in his computer. Okay, but he still needs to load it into R for R to use it. For now, he's yet to use it in R. So you use another function. Sorry, Dr. could you? Okay. Now you need to use library function. So Josh, type library.
Okay, sir. I'm trying to look at the part. User document. Type library.
Yes. Just type lib. Press enter because it's there already. And then type in the name of the package. Read Excel. Type REA. It will bring it up. Press enter. Then press enter again. Okay, so now R is not trying to load good. So that package is now loaded into R. So you can now work with it now. Now, we are going to find the file and load it, the Excel file. So first of all, we need to get the path. Now, there are different ways to do it. Okay, let me go to the simplest way to do it so that you won't have to memorize or find a way to know the path. So Josh, go to your files.
Yes, sir.
There in R, just at the right hand side, you can see a place called written files. Click
Yes.
it. Can you see it?
I should go to my file.
Yeah, here in R Studio.
Okay, in R Studio.
Yes, at the right, you use the environment to cover the file plot packages pane.
The file.
So, no, sorry. I mean, R has 4 panes: the script pane, console pane, environment pane, and then the file plot packages pane. So
Okay.
bring up your file plot packages pane.
Yeah.
That's the one, the right down pane. Okay, if you remember, I told you, as we enter into go into R, what we learned earlier is what we need to communicate in our language. Yes, you used the environment pane to cover it. Good. Now it's up. Good. Now, okay, you are in your downloads. It's like the downloads is empty. So which folder is the Excel file you want us to use?
My documents.
Okay. Can you click user? Is it there?
It's under this user.
Good. Click that user. Good. Go to your documents. Fine. It's here, right?
Yep.
Okay. Now, there's something called working directory in R. I've not taught that. In R, we have something called working directory. I'm going to find a way to explain it. A working directory is where R can work from. As of now, if you look at Joshua's console pane, at the top where at that page where you see R 4.5.0, beside it you see a path where you see user downloads. So it means that whatever file you want to call up in R, whatever thing you want to save in R, in this your current session, it saves in that path, in that folder. So now, since you want to call up an Excel file in this folder, in documents, we need to change this working directory to documents, so that we don't have to type the whole file path to be able to call up the documents. So now we're going to use a shortcut in his file work packages pane. Now, so we're going to change his working directory from these downloads to documents. I don't know if this is clear, because we can understand this. Please, can someone make a comment? Is this clear? Do you understand this?
Like to know. Where we can hear you.
Okay, do you understand what I mean by working directory? It's not so clear yet, right?
Working directory just means that's your, let's call it,
Good. It's good, yes. Something like that. It is.
like that's
it to move to another place. So, like when you install your R, it has like a default, let's call it folder, where, for example, when you save, it just saves to that particular place. So by default, most likely maybe going to be maybe your documents or downloads or whatever. So, but if you need to change, you can now say, okay, save to desktop or save to this or that or that. So what it's saying is that to make it easier for you to locate the exact file you want to work with, it's best you put it in the working directory where R is, so that it will just pick it from there. You don't have to like link and go to different places. I don't know if you.
Yeah, thank you, the process, for that explanation. Okay, so now, okay, since we are on working directory, let me just talk about it a bit. So now there's also a function to see working directory. Set WD or to check working directory. I've forgotten the function. I know to set working directory. Okay, go to working directory. Okay, get. Good. So to check working directory, we use the function get WD. So George, can you type it? So we're supposed to see this same thing. Get WD, open, close brackets. Josh, I want you to use the help of R. Clean it. Press, once you type first three letters, R helps you out. I want you to learn to use that R's help. GET. Okay, type W, so it's down, down, down. Or okay, so it's there. Okay, I want you to press down button. So you see, able to go through other functions. So now get WD and press enter. So it shows you they get working directory function. So press it again to run the command. So you see, this is something with the one as above, telling us where our current directory is. Now we want to change this to documents. Now going to our file packages pane. Now look at that place that is more. Can you click that more?
The place that is more.
Yeah, I mean in your file plot packages pane.
Okay.
And look above, you see more.
More.
Good. So you see, set as working directory.
Set as working directory.
Yes.
Okay.
Click it. Good. So look at our console. You see what has happened. So, and if you look above too, the document is what is now a directory, but it didn't show
So
documents.
that above, I don't get that above. The above they are talking about.
Okay, yeah, but I mean that if you look at your R 4.5.0, and beside it you see where it wrote what do you call this sign? This stroke. So it has changed your working directory. So you're no longer download is no longer your working directory. So
Thank you, sir.
we have now changed our working directory. So now we can now easily refer to any file in this place now. So this is documents. So now, so can you repeat get WD? Let's see what it will now show us. So just press up. Clean, press up again. Good, enter. So you see, so this is now our current working directory. So I hope you can see it. Good. So now, we now use a function in the Open Excel package to now access an Excel file in this directory. So the function we'll use is read_Excel. So type read. Aha, good. So go to read_Excel and click it, or you press enter. Good. Now we need to mention the file, but it needs to be in a string format. So use double apostrophe. So can you type double? Okay, though I think it can work with single. It's okay. So good. So type the file name. Remember, R is case sensitive. You need to include the file extension name. You save it as an XLS, as an XLX or XLXS file. No need to check. We can. It's already here. So just from your file plus packages pane, scroll down to the last, and you see everything there. Okay, tutorial.xlsx. Yeah, but you see there is a $ meaning that the file is open. So R cannot access it if the file is open. So you need to put it in your computer. Good. Now it's closed. R has given us the story. Like, so now, okay, good. Now you have called this. There are some other functions that you need to call. You may need to specify the sheet. So it depends on what you want. Do you want R to give you everything in one sheet, or a specific range in one sheet? So what do you where is the file where is the data you want us to access? Is it in a particular sheet, or is it in a particular, maybe the sheet has other things, but you just want to extract only a small part of the sheet?
The data is in sheet 1, and the workbook only has one sheet.
Okay, so that sheet 1 has only that data in question. It has no other thing.
No other data.
Okay, good. So we can call up the sheets. This thing, write sheet equals to. Okay, yes. After the last apostrophe, put comma. Then type SHE. Good. You see, sheet equals to. So there are different ways. You can just type 1. So R recognizes that as the first sheet. But if you want to use the name, you now have to put apostrophe sheet 1. But since it's just 1, just type it as 1. And then, yeah, that should be it. So press enter. Let's see. Yeah, hold on. R is coming. So this is it. Is that what you typed in the? Is that the data that you want us to work with?
Yes, sir.
Okay. So I can see there are issues with this data extracted. The defaults are setting for this package is that it sees the first row as a title row. You can see the first thing you typed was 6888.
Can't remember.
You can't remember what you typed. Okay, check the data because I recognize that as the title of the column. And you can see it has eight rows there. The
One
first
column. Yeah, 688.
so that 6888 ours read it as a title column. So but at least you're able to read this data. So we can decide to summarize this data. What I want to do? Okay, I want to redo this.
I made changes to it.
Oh, okay, I can see. All right. Okay. So now, okay, I saw it as double. It's double. I don't know why but anyway, double is okay. It's a numeric double that R read it as. So my
So that
data,
for context, I want the data, the changes I made was to the Excel file on my drive, and then I run the function again, then it picked it, just to mention that.
it's okay. It's okay. Okay. So now we've read this for this file. Is there anything you want R to do for you again? Because there are 100 things in my mind, but I don't want to be too forward. So let me wait to hear what you want R to do for you. R is just anything you want.
Okay. This is a very small amount of data. We would have maybe the length of the data, which greater than, less than, all that. But I think what brought us here, we already achieved this from like picking and a file from our local drive to Excel to R so that we can work with it. So from now we can do anything we want to do with it from here. So that's this answer.
Okay, it's okay. Okay. Any other questions, comments from anyone?
I hope it's not I'm jumping. So what if there were different data on that same sheet? You wanted to mention it the other time. So you said that we have to add something to this sheet is equals to one, like to sort of extend it. Or how do we go about it? Like if we had like on the Excel file, we had one sheet, and then on that one sheet, there are different set of data in different places. Let's say maybe we have control, then we have about three columns or thereabout, then we have vanadium, then we have like different data. So and then we want to extract one particular data alone, not the whole sheet. So
All right. Yeah, I get that. Um, that's where we use the range function in the read Excel. Okay. Let me break it down for you to understand. Each package works differently. So Josh, um, I want you to go to the help file for the read Excel function. If you remember in our first thing, so in one of our classes where I showed you how to go to help, how to query R for help in functions. So I want you to see what that read Excel can do and explain it. I don't know. I hope that will be okay. Go ahead. No, I don't want to query the entire package. I just want to query that read Excel.
I have read
Read underscore.
Okay. Okay. Right.
Clean everything because. Oh, okay. Go ahead. You can type it then. Okay. Clean the art. Okay, go ahead. I can see it there. Read underscore Excel. Good. So press enter. Good. Please expand that help pane. Good. So you can see under this read Excel function, there are many commands you can call up under it. You can see the first one after the read underscore Excel. First one is path, followed by sheet, followed by range, followed by call names, call types, NA, trim underscore WS, skip, and so there are lots of functions you can call up. So, but to answer James' question, that comes under range. Okay. Based on this function, read underscore Excel, you know it's a package under the read Excel package, which we installed and loaded into our library. So if we want to extract a particular place, so we put a read underscore Excel, then put our path. Remember that our path in the case that we just did, because we are already in the working directory, we didn't call the full path name. We only called the name of the file because we're already in the directory. If not, we would have called the full path name at the C is to double slash this slash this user file this. So, and then we now call the sheet equals to 1 or 2 or 3 or under inverted commas, we now write the name of the sheet. So under range, we can now call the range. Let's say, for instance, now our data is between B1 and D22. You know, so you can now come after you call the path. You may also call the sheet, and then now call the range as B1 is to D55, and that is how and then you now close you now run the command. I don't know if that is okay. So but you know this function has Joe, scroll down more on that help function. Good, keep going down. So it has other ones. Good. Good. Stop here. Good. Now you can see path is explained. Sheet is explained. Okay. Now you can see where it said sheet to read. Enter a string bracket the name of the sheet or an integer. That's the portion of the sheet. Remember, I've already explained this. So where you can use an integer as the number 1, 2, 3, or based on the position of the sheet, or you call the name of the sheet in inverted commas as a string. And the string means that one place in inverted commas. And then the next one is range. So you see range, you can call the range. Okay. Now, if you look at this range, there is a comment it made there, which I think I should highlight. So it said a cell range to reach from as described in this includes typical Excel range like B3 to D67, possibly including the sheet name like this and more. Interpreted strictly, even if the range forces the inclusion of leading or trailing empty rows or columns, take precedence over skip just and sheet. Okay, so what this is telling us is that okay, look at under sheet. It says look at under sheet, the second line. It said ignored if the sheet is specified via range. So you see that comment, it tells you that if you specify the sheet under range, that command supersedes whatever you write in sheet. So mean that you can call, you can see under sheet, under range, it gave it give an example. Budget with an exclamation mark, B2 is to G14. So that with that is supersedes whatever you may have written in sheet. I think this may, I don't know, am I speaking so much Greek? Or okay, let's practice. Maybe that would come home more. Josh, do you have another Excel file that is complex that would be nice to work with? Or okay, let's still work with this. Let's modify the command. Okay, so go to your console, call up the commands, read Excel, blah, blah. Oh, okay, good. Now, okay. Remove, delete sheet equals to 1. Good. Now type range equals to. Now type 1 with exclamation mark. Aha. Now looking at this data that you gave us, okay, decreased the things inside. Okay, for
Yes.
1. Okay, good. Now I want us to just extract from okay, let's say from 9 to the end. The end is what again? Okay, from 9 to 17. Okay.
Okay.
So that would be 1 exclamation. Because I know that's 9 will be 10. So write A10 is to A17.
Those are the cell number from Excel, right?
Yes, exactly. A10 is to A17.
I use colon for 2.
Sorry?
A10 to.
Yes, A10 is to A17.
Like that to, how do you represent it in R? Is it colon or
Okay, yes,
hyphen?
it's colon. Sorry, colon. Yeah,
A10 to.
A10 colon A17. Okay, no, that should be 18. Because it's 17 here, but in Excel it will be 18. Because we didn't count the header column, the header row. So it will be +1. You understand? So now press enter. Okay. Okay. I know why. So just press up. Let's modify the command. It's doing this because it expected that 1 to be a sheet name. So it's either we call the sheet name under the sheet equals to, or we change that to sheet 1. Then Excel, then I recognize it. I don't know if you understand. So in front of 1, type sheet. Capital S. No. In front of 1.
In front of 1, before
Yes,
1.
before 1. Capital
Okay.
S, then small letter HEET. So press enter. No space. No. Sheet 1. Why is it giving us an error again? what's the name of maybe is the sheets? What's the in Excel? Is it sheet one?
I think it's just sheets.
If not, we just we just call the sheet function equal to one, then the range to avoid all these naming because the name is not in line with what
Sheet one. It's sheet one.
small letter, everything.
No, capital S. Just like we typed.
Well, the spelling might be wrong. Something is wrong. Why it's not giving us what we expect? Well, we'll just call the sheet function to avoid these nomenclature issues. So go back to the command that we called. So just go back to the console, press up, then they delete the sheet one exclamation mark. Okay. All right. Then type before the bracket, type comma sheet equals to 1.
Right.
Press enter. Oh, okay. Sorry, I found where the error is from. Go back. The whole thing is supposed to be a string. Go back again. Let's go back to the original. This okay. No, go back down. So put no back again. So put another comma for the whole sheet one to the end. The whole range should be a string. Then put at the end too after 18. Press enter. Okay. So this is it, but it's telling us that there is nothing in that space. So what will happen is that maybe it's this same sheet one issue has a problem. So let's go back to our last one and only put A10 is to 18 under that apostrophe. I don't know if you understand.
Our last.
Go back again. Go back. Good. Now I know. Good here. A10 colon A18. Put them all in inverted commas. That should solve it. After 8, press enter. It's saying there's nothing there. Josh, where the data? Which column is the data in the Excel file? Can you open it?
Okay, let us open the.
It's telling us that there's nothing in that in the area that then needs to bring up. Because 0 times 0 means that there is nothing in those.
My data for the previous one is on row 2, sorry. Dr. James is on row 13, while the last value is on row 19.
What is the column? The column
column B.
Oh, you see. So that's why we are having all these issues. So
okay, we're using A.
Yeah, so it's B. So do the necessary corrections and we'll see our data pop up.
I think understanding error code is another tutorial on its own.
Sorry?
Understanding the error so that you can
once you are into coding, programming, error is like your second brother. So you see, so with time you understand errors, and sometimes errors can even make you go mad because you wonder error. Where is it from? Can take you one whole day. When you get the error done, you're like, wow. So that is what happens. So we're not going to be able to solve this. So you can see our data. All right, I think we should call it today. We've really spent a lot time on this.
So I want to save this
Okay, to save is another function. I already searched already for it.
I don't want to lose this. I want to save it. Save this script.
Okay, the script.
Yes.
I think it's
Okay.
recorded.
Oh, sorry. We are doing this in the console and not in the script. So no problem. You can. It's in the environment. Okay, go to your history in your environment pane. Your environment is collapsed. You collapsed your environment. You know there's an environment pane above your 5 plot packages pane. Environment history. Aha, good. So go to history. So history shows you everything we've been doing in this R session. And actually it saves by default in your working directory.
So
But it only shows you the commands. It doesn't show you the results or the outputs of everything. So what do you want to save? Do you want to save this history?
yeah, since we are working on the console, I could not save that. Let me save the history there.
Okay, so it has both the one that had errors and the one that we are okay. Okay, so it's okay. Actually, when you end your session, it saves in R. Okay, so good. Save it to a file. Good. So you can click that place and then
File type. Why is
yeah,
R?
history, yes.
Okay.
It's actually a text file. These are all text files, but they have different extensions. In fact, when you go into genetic data analysis, there are many file extensions, but they are all text files. They're not given different extension names. Okay, I think that should be all. We really spent quite a lot of time today. Thank you all so much. So, any other question or comments from anybody?
Dr. Augustine is asleep. Dr. Chenry is outside. Dr. James, myself, and yourself. I think Villa as well.
All right. So thank you. See you.
Thank you so much, sir.
Thank you so much, sir.